Xenotransplantation describes the transplantation of cells, tissues, or organs to a recipient of different species. Xeno comes from the Greek meaning of foreign or strange. Transplantation is the process of taking an organ or living tissue and implanting it in another part of the body or in another body. Xenotransplantation aims to replace standard allotransplantation, transplantation from human to human, which is right now incredibly inaccessible and complicated. Currently, it is in a research stage, and it is not ready to replace allotransplantation. As will be discussed and explored in this video, there are many issues regarding the bioethics of xenotransplantation. As mentioned, allotransplantation is an incredibly inaccessible procedure. As of right now in Australia, there are 1,800 people waiting for a life-saving transplant, many of whom will never receive one. Advocates and researchers of xenotransplantation outline how it has the potential to provide an infinite supply of organs in comparison to allotransplantation, which only has the capacity to treat a select number of people. During an interview with xenotransplantation researcher Hugh Auchincloss, he was asked, "Would you like to see xenotransplantation work?" He responded, "If we truly had enough organs to go around, we'd have the opportunities to treat new diseases and to treat different kinds of people who currently aren't even candidates for transplants." As of right now, xenotransplantation is still in its research stage and is not a standard procedure to any capacity. Xenotransplantation procedures have only been performed on a handful of patients, all of which were experimental procedures. In recent years, there has been a range of developments with xenotransplantation, especially with pigs. Currently, pigs are the choice for xenotransplantation procedures. Pig organs are comparable in size to that of humans. Pigs are also domesticated animals that can be easily raised in relatively controlled confinements, which is not the case with non-human primates. Additionally, pigs have a large litter of up to a dozen piglets at a time in a relatively short gestation period.
For years, researchers have worked toward transplanting animal kidneys into humans. It's a race against time. There are almost 600,000 Americans on dialysis in need of a life-saving kidney transplant. 240 Americans die every day on dialysis, and many of these deaths could be prevented if an unlimited supply of kidneys were available. Pigs are the most promising donor source. Researchers have been able to genetically engineer pig kidneys that can coexist with the human immune system. Surgeons have made multiple attempts to transplant animal organs into humans. But no one has been able to demonstrate how the entire process of transplant of a pig kidney to human would work in the real world. Until now. In seminal peer-reviewed research in the American Journal of Transplantation, a team at the University of Alabama at Birmingham revealed the results of the world's first clinical-grade pig-to-human kidney transplant. Notably, the study was conducted to meet the same standards as a Phase 1 clinical trial, making it mirror, as much as possible, every step of a normal transplant between humans. They started with unique pigs, genetically engineered with 10 gene edits. 3 deletions disabled genes that would trigger the human immune system and cause rejection. A 4th deletion prevents the kidneys from growing too large in the recipient after transplant. The rest are human genes added to the pig genome to prevent the recipient's immune system from attacking the organ. A herd of donor pigs live in a DPF, a designated pathogen-free facility designed for clinical use. The human recipient was a brain-dead man whose family gave permission for this crucial test of animal-to-human organ donation. Pig donor kidneys must be tissue-matched to human recipients, just like human kidneys. The UAB team designed and performed the world's first test to ensure tissue compatibility from a pig to a human. In separate tests, the researchers also confirmed there were no viruses transmitted. Both are critical to the wider implementation of pig-to-human kidney transplantation. After the pig's kidneys were removed, they were transported to UAB hospital, just like a human donor organ. Meanwhile, surgeons removed the recipient's kidneys. Then they attached the pig kidneys to the recipient's arteries and veins, as well as to the bladder. Within 23 minutes, the kidneys had produced urine. The kidneys remained viable and made urine for more than 3 days. And genetically modified pig cells were not detected in the recipient's blood. This study is an important step toward ending the organ shortage and preventing tens of thousands of deaths each year.
As mentioned in the video, this experiment was promising possible treatment for the 600,000 Americans currently on dialysis and the 240 of them that die every day. Figure 1 demonstrates what organ on the American National Transplant waiting list patients are waiting for. As seen on the left, kidneys are the largest majority of any organ. This figure makes up 86% of all patients waiting for an organ transplant in the United States, which demonstrates this experiment's significance to benefit a significant amount of people. Critics of xenotransplantation outline the possible disease and rejection risks it may pose. Xenotransplantation is an alternative to allotransplantation, which already brings pathogenic risk to humans. Xenotransplantation procedures bring the risk of unique zoonotic infectious agents not usually circulating in the human population. However, a pool of specific pathogen-free donor animals may be useful to overcome this issue. A vascularized porcine organ is rejected more vigorously compared to current allotransplants because of the genetic distance between primates and pigs. However, it is important to note that due to genetically modified pigs and developments in immunosuppressive therapy, survival times have improved. As put by the book Life's in the Balance, The Ethics of Using Animals in Biomedical Research, there is no shared religious or philosophical worldview which might dictate an agreed answer to the question of how we can adjudicate on conflicts between obligations owed to humanity and to animals. This excerpt highlights the complications of attempting to find a single view that could justify xenotransplantation experiments ethically for all individuals, as there are so many conflicting factors of people's views on such topics. Thus, it is impossible to ever be able to satisfy all viewpoints of xenotransplantation with one shared view. In the current ethical framework, a clinician does not require consent to perform transplantations, and in an emergency situation usually would place the patient on an emergent human liver allotransplant. In a scenario where the pig liver transplant is a reasonable alternative, the clinician would have to choose between placing the patient on the allotransplant waiting list or performing an immediate xenotransplantation. Many ethical concerns regarding xenotransplantation come from that of religious, disease, illness, and animal welfare concerns. If xenotransplantation were to become a standard practice where it replaces allotransplantation, an ethical framework needs to be put forward which will regard the specific conditions in how it is undertaken. This ethical framework should account for all categories of concern mentioned, those being animal welfare, religious, and human health impacts. To summarize the points of xenotransplantation this video has covered, it is a medical procedure where cells, tissues, or organs from one species are transplanted into another, which may one day be a potential solution to the shortage of human organs for allotransplantation. Recent developments in xenotransplant experiments in pigs, for example, the video of the first gene-edited pig kidneys into a human, are huge steps forward in the field of xenotransplantation. And it is to the researchers' hopes that one day xenotransplantation will provide an infinite supply of organs for transplantation. However, if this point were ever to be reached, it would be essential for it to include a solid ethical framework and ensure the practices are safe from pathogen transmission.